All right, so using the information in this diagram, we're supposed to decide which one of these statements would help us prove that the triangles are congruent. Remember the things that will, let's not jump the gun, it's not time yet. Remember the things that help us prove triangles are congruent. They are, sometimes we have side, 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 angle, side, angle, side, angle, 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 side. Remember that side, side, angle does not help us, and angle, angle, angle does not help us. So, look at option A, angle BJP. Let's see, BJP, focus on the J, and is congruent to angle ZQM. So that would be this. So, if I know that those two angles are congruent, do I now have enough information to know that the triangles are congruent? Okay?
No. Makes a bad word.
Right. This would not help us because this would be side, side, angle. All right? It's the two sides and the angle that's not in the middle. Side, side, angle is a no. That one doesn't work. So that's why A will not help us prove that triangles are congruent. So it's definitely not A. So let's look at B instead. Okay? Looking at B, it's a PBJ, PBJ. Okay? So that's this one. And is congruent to MZQ. MZQ. That would be like that. Would that be enough information to know the triangles are congruent?
Yeah.
Yes. Which one of those theorems is it?
Side, angle, side.
Yes, that would be side, angle, side. So B would definitely work. Did anybody think there was another one that also worked?
E. I did it. I thought you
He
looked down, too.
Made you look. What grade did that stop being funny? I forget. Third grade? Third grade? All right. Any questions about number one? Any questions? All right. Didn't you have your hand up? Did you have a question? No? Okay. All right. Number two. Calculate the slope. Yeah, so these three right here involve formulas that, Haley, you just have to memorize. Okay? These are formulas that will not be given to you. You have to practice them, memorize them. Write them down, make flashcards, whatever you need to do. Maybe you could make one of those flashcards like I make on Quizlet or whatever. Right. So anyway, for slope, please understand that the slope formula is like you do y minus y over
X minus X.
Correct.
Yay.
Okay?
Are you recording this?
Yeah. So slope is y minus y over x minus x. So in this case, that's going to be, so y minus y. So that would be like 5 minus 2 over 4 minus negative 1. Huh.
That's funny. Oh,
I'm going to put 4 plus 1. Why did I do that? Because I'm doing 4 minus negative 1. And I understand that minus and negative is the same thing as plus.
Because key change.
Yes.
Same
Yes.
change.
Okay. So that's going to be 3 over 5. So the slope is 3/5. Any questions about number 2? All right. Just, you must learn the formula. You must know the formula. Head up, Chase. Don't put your head down. All right. Number 3. What is the midpoint? Okay. Mason, hold the talking, please. That's 1. Midpoint is also a formula that you need to know. I tried to convince you that the midpoint is just the average. The average of the x's is the x value of the midpoint. The average of the y's will be the y value of the midpoint. So that's all it is. So in other words, the midpoint, if you wanted to think of it as a formula, it would be like x plus x divided by 2, comma.
Y plus Y divided by 2.
Yes, sir.
Equals.
Okay? So that's the midpoint. That's the formula, if you will, for the midpoint. But it's just the averages. So if I use that, then it's going to be like this. It's like negative 1 plus 4 divided by 2. That's the x's. And now the y's. 2 plus 5
Divided by 2.
divided by 2.
So simple.
And what does that simplify down to?
3 over 2.
3 over
comma
2.
7 over 2.
3 over 2, comma, 7 over 2. That is the midpoint. Some of you guys neglect to put parentheses around your ordered pair. Those are not optional. You know that it's a point, an ordered pair, because of the parentheses. So please use parentheses.
That's the answer. Toggle
Yeah, I guess, since I didn't specify, but in general, don't go decimals unless I tell you to. Okay, any questions on number 3? Okay, just know that formula. And again, for number 4, this is yet a third formula that you just need to have memorized, bring it back to the front of your brain. What formula am I referring to now? I'm referring to the distance formula. It'll help you remember it if you understand that it's really just the Pythagorean theorem written in a different way. But the distance formula works like this. It's the square root of x minus x squared plus y minus y squared. Now I mentioned the Pythagorean theorem. These parentheses, it's like my a squared plus b squared. So that might help you remember that it's all squared in there. It's like a squared plus b squared square root. So anyway, in this case, if I do that distance formula, it's going to be x minus x, so negative 1 minus 4 squared plus 2 minus 5 squared. It doesn't matter the order that you write those numbers in. You're going to get the exact same answer either way. Okay? You got root what? Root 34. Do I have a second?
I got root 34.
Also root 34?
I second it.
Okay. Motion carries. So the root 34. Is anybody getting something completely different? We need to talk about it.
I got 35.
Anybody else?
What does that triangle mean?
It means, you mean in front of JKL? It means triangle JKL.
Yes.
Well, in chemistry, it means change.
Actually, it's heat. Mine means
Heat?
heat. Yeah.
Are you sure? Really?
I thought it meant change.
No.
Oh.
All right, anyway, number 5. We're supposed to find out if this triangle is equilateral, isosceles, or scalene. Of course, what does equilateral mean?
All the sides are the same.
All the sides are the same. What does isosceles mean?
Two sides.
Two sides are the same.
But they also.
So what does scalene mean then?
None of the sides are congruent.
None of the sides are
One
congruent.
side is
So what's my strategy? What am I about to do right now?
Distance formula of distance.
We're going to do the distance formula 3 times.
Oh,
And that we'll be able to see if they're all the same, equilateral. If only 2 are the same, isosceles, and so on.
do it.
Okay, so question?
Does it matter if you do like 4 minus 2 instead of 2?
No, you should get the same answer either way. Okay, so these are the lengths that we got from doing the distance formula. So what's our conclusion?
It's isosceles.
It's isosceles because the 2 that are the same. Yes, sir. What's up? Talking about the line? What about it? No, I'm good. But you do. You should do it. All right, number 6. Rosalind is cutting fabric to make a triangular scarf. Which of these could be the lengths of the 3 sides of the scarf? We kind of did this yesterday. Because remember, the 2 smaller ones have to be more than the biggest one. So, for example, I'm seeing the 24 is the biggest. What's 10 plus 12?
22, no.
All right, that's only 22, so that's a no. Okay, I'm looking at the 22. What's 10 plus 12? That's equal to 22, so that's a no. I've got the 21, but 5 plus 17 is what?
22.
Is 23,
Oh, it is?
Oh,
isn't it?
Yeah.
22.
22. No,
It's 22. which is more than the 21. So that's why C is the answer. Ding, ding, ding. Yay.
Now you're being like basic.
Okay. 5 plus 7 obviously is only 12. That was not enough, so just following through. D was not going to work. Any questions about why C is the way it is?
Yes, sir. No, sir.
So number 7, I gave you 3 out of 4 of the corners of a rectangle. You're supposed to find the 4th vertex there. Easiest thing to do is utilize the graph paper that I've so generously provided for you.
Generously.
Yes, I just threw that in there. So look, I've got the -3, -2. Go ahead and graph that. -3, -2 would be like right here. So that's like my D. 0, -4. That would be right here. Okay, that's my M. I've got this 1, 4. That would be like right here. That's my R. And then I'm supposed to find K. So if you're using the graph paper here, it should be easy to find what that other point is because of the symmetry of everything. Use your slopes. Let me say that again. Use your slopes. Okay? Look at DM, for example. What's the rise and the run of this DM side down here?
Up to 3 to the left.
Correct. Okay? Like if I go from D to M, let me change colors for a
It's gonna
second.
be,
Okay?
so it'll be 3 to the left,
No, 2
down
up.
2.
No,
Okay? See how it's like we're going down 2 over 3.
And then you just flip
Okay? So if I'm picking up from the R value, it should be that same pattern. Should be down 2 over 3 because it's got to be the same slope.
Yes, sir.
So if I do the R and I go down 2 over 3, look where I end up.
I am
Okay.
such a beast.
Okay? I should end up right there. So that better be the corner. This better be where my K is. And when you look at it, see how perfect it looks? It's pleasing and satisfying to the eye. You can kind of tell that you did it right. Okay? But what are the, we need the ordered pair.
It does satisfy my
It's like, okay, that's nice.
Someone got 2.
What are the coordinates, my friends?
4.
4, isn't it? 4?
God, 4.
4, 2? It seems like 4, 2.
It is.
Okay, so that was what we're looking for, 4, 2. That's the easiest way to do that. Flavon, keep that head up, buddy.
That's 1.
All right. Let's go ahead and flip over to the back, my children. Flip, flip.
I think I'm your student.
DRKM is a rhombus, blah, blah, blah. Okay, we had all those properties and such. The properties. Back in the day, I had asked you to take the time that it took to memorize. Everything here in yellow, those are the definitions of each one of these quadrilaterals. Everything that's on, like written here in red, those were the special properties of each of these quadrilaterals. And you were supposed to memorize them to the point where if I stopped you in the hall and said, what's the special property of a rhombus? You were supposed to say, that's definition. That's definition.
I thought you just.
Special property.
Oh, perpendicular.
Okay.
Something.
In the hallway, you should be able to go, oh, that's the one where the diagonals are perpendicular.
I would wait.
Also, the diagonals are angle bisectors.
I thought it was
Okay? So, it would have been nice if everybody memorized all those. Most of you never really did do that. But, okay, if I can't get you to memorize them all, can I get you to at least memorize like a couple of them? Because most of them are common sense. So even if you don't memorize them, you might correctly guess at them because they fit your common sense. But a couple of them are not common sense, so it would help you if you memorize them. So here's the one that I want you to definitely memorize. It's the one I just said. What's the first special property of a rhombus?
diagonal perpendicular.
The diagonals are perpendicular. That one doesn't just automatically pop into your head. okay, unless you memorize it. The diagonals of a rhombus are always perpendicular, 90-degree angles. Please memorize that one for me.
Wait, did you say something, Mr. Bunny?
The diagonals of a rhombus
Okay.
are perpendicular.
Okay. got it.
That's the special property.
All right.
While we're at it, that's the special property of another shape too. So we might as well do 2 for 1.
Where?
Well, a square is a rhombus, so that doesn't count.
Rectangle.
I'm talking about another non-rhombus.
Rectangle just
Kite.
and a kite.
Kite. Kite. Okay, the first, for a kite, same thing. The diagonals are perpendicular. So if you don't memorize anything else from this list of special properties, at least memorize that a kite and a rhombus have diagonals that are perpendicular. Perpendicular. Kite, rhombus. Okay, got it? So at least memorize that. So hold that in your brain as we go through number 8. Okay?
Yes, sir.
Because it says rhombus, the diagonals are perpendicular, remember that. It will help us if we do a diagram, so I'm going to do a diagram. Okay, so here's a rhombus. Let me throw some letters on there. So D, K, wait, D, R, K, M. So D, R. No, we already given the letters. But the letters are already given.
Don't change it.
All right, so looking at option A, side DR is radical 3. So I'll put a little radical 3 over there. If side DR is radical 3, does that mean that KR is radical 3 also?
Yes, sir.
Yes.
Wait a minute.
Yes, it does, because it's a rhombus. What's the definition of a rhombus?
All
All
sides are
sides are con.
It tells you it's a rhombus.
It tells us it's a rhombus, yes. So that's 4 congruent sides. So yes, if DR is radical 3, then KR is also radical 3. So that one is always true. Look, we're looking for the one that is not always true. So we will scratch out A because that is always true.
Boom.
So let's move on to B. All right,
Which one is B?
let's move on to B.
B is in Brian.
So let's see, slope of DK is 3.
B is in Bob.
Okay, slope of DK is 3. DK is a diagonal. So say if the slope of that is 3. All right, I drew an arrow to remind me that this is supposed to be the slope now.
Yes, blame it on.
So the question is, will the slope of RM always be negative 1/3?
Yes, sir.
B is in
Okay,
Bob.
so
Yes.
RM is the other diagonal. Okay, so what it's saying is, look, the first one had slope 3. The other one had slope negative 1/3.
Oh, B is in Bob.
Okay, wouldn't those be the slopes that you would get if you had perpendicular lines always?
Yes, sir.
Right? Remember, get this back to the front of your brain. That's why we're reviewing. If lines are going to be perpendicular, their slopes have to be opposite sign and reciprocal. Like 3 and negative 1/3. One's positive, one's negative, and they're reciprocal.
Right.
3 over 1, 1 over 3.
Let's see.
So, but what did I just tell you? What's the special property for a rhombus?
Diagonals are perpendicular.
The diagonals are perpendicular, always perpendicular. So since the diagonals are always perpendicular, if one diagonal has slope 3, the other one will always be negative 1/3 because they're perpendicular. So B is again always true. So B cannot be the answer.
B is in corn.
So we'll have to cross that one out and keep looking. So let's move on to option C. The slope of DR is 1/2.
I think that was right.
Okay.
I don't know why.
Yeah.
I think it's right.
Go, B, C.
All right, the slope of DR. So say the slope of DR is 1/2. Does that mean that the slope of KM is also going to be 1/2?
Yes, because they're congruent.
Oh.
Yes. Okay, a rhombus is a special kind of parallelogram.
How'd you find it?
All right, every rhombus is a parallelogram. So opposite sides should be parallel, meaning same slope. So if one is 1/2, the other one will always be 1/2.
D is in dominate.
So C, once again, C is always true. So that's not going to be our
Chad,
answer.
you said C was correct.
So
Who said that? Brian said
I
that.
said it, and I admit.
the answer must be D.
It was Salsa.
Well, let's go ahead and analyze and see why. Jet and Brian. Quiet mode. That's one.
There's sides in that.
Wait, Brian is the one or me and Brian?
I can explain to you why.
Let's talk about why D is the answer. Go ahead. Explain to me, Lisa.
Okay, so DR is sides, and all of them have to be congruent, and DR is 1/2, while RK is just -2. They're not supposed to be perpendicular, it's supposed to be congruent.
Let's see. Right. Okay. The DR has slope 1/2. Does that mean that slope RK is always going to be -2?
No.
Well, does that look familiar? What does it mean if there are like 1/2 and -2? How do they look if the slopes are like that? Blurt it out. How do they look if that's how their slopes are? Just say it.
Like a rhombus.
What does that mean? Say it louder, please. Right, perpendicular. Perpendicular. These slopes are opposite and reciprocal. That means they're perpendicular. Does a rhombus always have to have corners that are perpendicular?
Wait.
Do these vertices, do these angles always have to be 90 degrees?
Yeah.
No.
Not for a rhombus.
No, not for rock.
Only if it was a square.
Or rectangle.
Okay? So, in general, a rhombus, because remember, I mean, let me make it more exaggerated to make a point. This could be a rhombus right here. Get off.
But he's like really small.
Okay? This diamond shape that's a rhombus. Is this 90 degrees up here? Obviously not. So it does not have to be 90 degrees. So that's why D is not always true. Only if it happened to be a square would it be perpendicular. So moving on to number 9, 10, 11. You guys are usually pretty good at these.
I think I'm not.
Except for, look, on number 9. Here's the mistake kids make a lot. A lot of times kids, you guys just want to set everything equal to each other. All right? Whether or not they're equal, you guys just set everything equal to each other.
Yeah.
On problem number 9, are these two angles going to be equal to each other?
No.
No. One of them is acute, and one of them is obtuse. All right? We have a small angle and a big angle. So they will not be equal. Do not set them equal to each other. What is the relationship between these two angles?
Well, they
Say it louder. Supplementary. Okay? What does supplementary mean, class?
They make 180.
Right. They have to add up to 180.
So we combine like terms. So 80.
Correct. So we're going to start off with equations like the following. You know what? I'm going to zoom. So these two angles should add up to 180 degrees. So in other words, 7x minus 28 plus 10x minus 13 should equal 180. They're supplementary. So combining like terms, 7x and 10x, you know, that's 17x. Negative 28 and negative 13, that's negative 41. Thanks. So we have this. Obviously, we're going to add 41 to both sides. So that's going to give me 17x equals. So that's 121.
Wait, what?
No, 221.
That's when
You can't add.
What a simple mistake.
I was getting there. So then, of course, we have to divide both sides by 17. Yup. So that's going to give me x equals, what, 13? Yes, sir. What do you mean, getting hyper?
I don't know why, but it's like, I just want to not sit down.
I feel the same as you.
I think that's why I like running track.
All right. Sometimes it helps if you teach because that helps get your energy out. That's right. And call on people and be like, that's one. Sit down. Now,
I kick you out.
on this problem, they actually are equal to each other. This is number 10, by the way.
Are you gonna do all of them from 9 to 14?
No, he does not have time for all that.
I don't know, man.
He should
Can you
do
do
9.
number 14?
No, he should do 9, 10.
I promise to get to 14. Now, stay tuned. So that's going to be 7x plus 4 equals. So this is going to be 7x plus 4 equals distributive property 3x plus 24. Subtract 3x from both sides. Yep. So that's going to give me 4x plus 4 is equal to 24. Subtract 4 from both sides. That's going to give me 4x equals 20. Divide x equals 5. Yes, 20 divided by 4 is 5, my friend. This one is a rhombus, a square. Well, okay, square is rhombus. I wasn't wrong. The point is, these sides, even though they're consecutive, they should equal each other. So these are equal. Subtract x from both sides. That's just going to leave me with x minus 14 equals 15. Add 14 to both sides. That's going to give me x equals 29. All right, that was number 11.
That was number 11. Boy, you got hit 10, 11.
OMG. Number 12. This is a rhombus. What did I just say about a rhombus not 7 minutes ago? Special property.
Diagonals are perpendicular.
The diagonals are perpendicular. Once again, that knowledge comes to our assistance.
And
Since this is a rhombus, that means how many degrees is this here in the middle?
90.
That means this is 90 degrees. That means 3x has to equal 90. So if I just simply divide both sides by 3, x equals 30. It's just that easy.
2K.
You two can be a geometry master. All right, number 13. Are these angles always going to be equal?
Yup. No.
Not always. They don't have to be congruent. This is a trapezoid. It's not a parallelogram or anything. Okay? But there is a relationship here.
Isosceles, though. Right?
Doesn't look isosceles.
The legs are.
Oh, true.
What's the relationship between these consecutive angles?
There.
Starts with an S.
Supplementary.
The angles like these are supplementary. What does that mean again?
180.
They should add up to 180.
So that should be 8.
So I should be able to find x. I should just be able to go 180 minus 91.
Equals.
89.
I didn't do mine.
Okay, so x is 89, guys. Guess how I'm going to find y?
The same exact way.
The same exact way. 180 minus
8.
132. Say it again.
48.
48.
You got it, brother.
Do you guys understand? Any questions? 13? Okay. I'm all about number 14.
Let's go.
Desafortunadamente, due to the number of problems that have to be done, there's no way to slow down. There's no way to slow down. But I am here before school, after school, if you need extra. Also, I'm recording this, so if you just need to go back and see it again, hit pause, think about it, just go back and I'll post this on Edmodo for you.
And brother, me and him, we going after school too, so if you want to come with us, we can hook you up too. All right, cool.
Okay. This is a kite. You can tell by the way it's marked, okay, with the consecutive sides being all congruent and everything. This is a kite. For kites, these symmetric angles, okay, like the 118 and this other red angle down there, they're always the same. All right, this has got this dotted line that I just drew. That's a line of symmetry.
That is completely correct.
Okay, so this is 118 down there. Know this. How many degrees are in any quadrilateral?
360.
360. I mean, if I really forgot it, couldn't I do n minus 2 times 180? But you should go ahead and memorize a quadrilateral, 360 degrees in
Guess
here.
what, Mr. Bird?
What's that?
I found the angle.
Yeah, me too, dog. You got 50?
Okay.
Me too.
So if you subtract everything from 360, so if you go 360 minus 118 minus 118 minus 74,
All right, that's a lot. It's 310, sir.
that's how you get the other angle. So what did the other angle turn out to be? 50
Yeah. Degrees.
degrees.
I was talking about
Okay, so angle X turned out to be 50 degrees. Are we comfortable with that, people?
Yes.
Mr. Burton.
Yes,
I'm
sir.
not trying to be.
Oh, better pause the tape for this. Okay, these questions are always, sometimes, or never. Okay, always, sometimes, or never true. A rhombus is always, sometimes, or never equilateral, class. Always. The definition of a rhombus is all sides congruent, so that will always be equilateral. The diagonals of a rectangle are always, sometimes, or never perpendicular.
Sometimes.
That's sometimes. Okay? What type of shape would always have diagonals perpendicular? Not a rectangle, but a rhombus. I could have said square, because a square is a rhombus. Or I could have said what other shape has perpendicular diagonals? Or a kite. If I had replaced the word rectangle with rhombus or square or kite, then it would have been always. But not rectangle. That's not one of the properties of a rectangle. Opposite angles of a rhombus. Opposite angles. Are they always, sometimes, or never supplementary?
Never.
Let me tell you why it's going to be sometimes. I understand why you said never.
Oh, just in case, like, it's all equal.
Right.
Okay.
What if it just happened to be a rhombus that was a square? What would the opposite angles be now?
90 and 90.
They'd be 90 and 90. Is that not supplementary?
It is.
So that's one case, but it's enough to make it a sometimes. Okay? It would only be supplementary if it were a square.
Can you say once in a while?
True. De vez en cuando.
I was just going to say that.
All right. A square is a rectangle. Always, sometimes, or never.
Sometimes.
Square.
Always.
Always. A square is always a rectangle. Look at this square.
Got it, brother.
Look at it.
Oh my God.
What's the definition of a rectangle?
It's a square.
All right angles. 4 right angles.
Definition of a rectangle is 4 right angles.
You got me there. I was going to say spell.
Does a square always have 4 right angles?
Yep.
Yes. So a square is always a rectangle. Always.
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 Never.
Always.
Diagonals of a rectangle bisect each other. That's always. That's one of the properties of a parallelogram. So any parallelogram, the diagonals will bisect always. Consecutive angles of a square are supplementary. Always, sometimes, or never.
Never.
Sometimes.
Never.
Always. We're talking about a square.
Oh, you said square.
Okay.
I meant to say always.
How many degrees are the angles of a square?
90.
90. All right, it's 90 all the way around. So if I consecutive means right next to each other. So if I pick any two angles, they're 90 and 90. That's supplementary. They will always be supplementary. Okay? Yes, sir. All right, I need to finish up this last part of the lesson. We're supposed to decide whether or not we are given enough information to prove that a quadrilateral is a parallelogram. Look, there are 5 ways to prove that a quadrilateral is a parallelogram. Here they are with examples. Starting with the definition, if both pairs of opposite sides are parallel, that's definitely a parallelogram. That's the definition. But we can also use these properties. If both pairs of opposite sides are congruent, like this, you know it's a parallelogram. If both pairs of opposite angles are congruent, like this, you know it's a parallelogram. If the diagonals bisect each other, cutting each other in half, that's definitely a parallelogram. The last one is the one that some kids don't always understand. If the same pair of sides is both parallel and congruent. See how these are both 5? And they're also marked parallel? Then this would definitely be a parallelogram. All right. On the other hand, if for whatever reason I had the 5s over here, whoops, I'm missing a piece. You know, if I knew that that was 5 and I knew that this was 5, this would not necessarily be a parallelogram. It has to be the same pair of sides that is both parallel and congruent if we're going to use this parallel congruent combo. Okay, it has to be the same pair like this. Okay, so 5 ways to do it. So if it's not one of those 5 ways, we're going to have to think long and hard to make sure we can do it. So number 21, opposite sides are parallel. Is that one of them? Yeah, that's the definition. So that's definitely a yes. Okay, number 22, opposite sides are congruent. Sure, both pairs of opposite sides are congruent. That's one of the ways to prove that it's a parallelogram. So that's a yes. All right, number 23. 2 pairs of consecutive sides are congruent. Yeah, that does not, that's not one of them. Please understand that the reason why that's not one of them is because we could be talking about a kite. You know, if I had a 3, and a 5, and a 5, this would be 2 pairs of consecutive sides that are congruent. But that would not be a parallelogram. That would be a kite. Okay, so that's a no. That's not enough information. Number 24, 2 pairs of consecutive angles are congruent. Now, all right, I'm going to try to convince you, even though I'm going to try to convince you that this is a no. All right, it's definitely not on the list of possibilities. Anything about 2 pairs of consecutive angles are congruent. But the reason why, picture a trapezoid. If I have an isosceles trapezoid, well, this is a pair of consecutive angles that could be congruent. And this could be another pair of consecutive angles that are congruent. But that does not have to be a parallelogram. It could be a trapezoid. So that is a no for that reason. That does not prove that it's a parallelogram. Okay, diagonals are congruent. Again, that is a no. And I can give you the same picture. If you have an isosceles trapezoid, guess what? The diagonals are congruent. This length and this length will be the same if this is an isosceles trapezoid. But that does not make it a parallelogram, so that's a no for 25. Number 26, that diagonals bisect each other. Wait a minute, have I seen that before? Number 4, diagonals bisect each other. That only happens for parallelograms, so that's definitely a yes. Okay, number 27, all 4 sides are congruent. All 4 sides are congruent. Well, guess what? If all 4 sides are congruent, what kind of a shape do we have? Yeah, that's a rhombus. And a rhombus is just a special kind of parallelogram, so that would definitely make it a parallelogram. So that's a yes. Consecutive angles are supplementary. Now, I'm not 100% sure of what they mean by this, because to me they could mean 2 things. If they mean all consecutive angles are supplementary, then this would have to be yes. But if they just mean, you know, 1 pair of consecutive angles, or even 2 pairs of consecutive angles, then that would be a no. Okay, so since it doesn't say all consecutive angles are supplementary, I'm going to go ahead and say no, because they probably mean like this is 60, this is 120. Okay, this is 60, this is 120. I've got consecutive angles that are supplementary. That does not make this a parallelogram. It could be a trapezoid. All right, so if that's what they mean, that would be a no. On a test, I'll have to make that more clear. All right, that's the end of this last little part of the lesson.